Good afternoon, dear AI practitioners. Before we start, and in order to introduce myself a little bit more, I work in Arvato Systems Latvia. As previously mentioned, I have 7 years of experience, and this is first time I present such topic for such big audience, so I'm glad that we are here today. And in order to start, I want to start with a definition of AI, since nowadays, here and there, we have those buzzwords, we are constantly speaking about AI, but who really understands what is AI, or who now from the audience could give me definition of AI? Anyone, random one. If you would say your child, what is AI? Robot. Some digital baby. Another one. But from my understanding, and in order to give you a common view, let's start with the more descriptive one. I think, or at least I found this and I like this, is that ability for a system to interpret, to learn, to use, and to achieve specific goals. But this definition is very broad. It gives me, at least for me, the technical vibe, more like a unhuman-like. And for that, I want to correct it and give you more plausible, which would be applicable even now and for any kind of system. I believe that AI is goal-directed adaptive behavior. And for me, it gives more human feel. So even the child who wants a candy will do anything and anywhere and all that he wants in order to give and to achieve that specific minor goal. Next one, I want to ask a question that will guide our journey today, which is, have you ever wondered how our fascination with the artificial led us to the revolution we see in the technological world today? And with that, I want to switch to the early beginnings of AI in the minds of the human. The aspiration of creating the artificial life began earlier than mid of 20s, mid of the Gauss, so it's 40s, long before. In this case, it all began in the old ancient myths, and in this case, it's Greek myth, Talos, which was the autonomous bronze man who was created to guard the island of Crete from its invaders with the formidable strength. Next one is the golem from Jewish myth, or specifically the Jewish folklore, which was once again animated being made from clay to again protect its people. And another one, which I guess could be the prototype or at least vision of the Tesla that we see today, is the Pushpaka Vimana, or the autonomous chariot, which was used for the prince to travel. So as we see, the vision of the artificial itself began long before we even started to think about its technological foundation, this scientific term. Next one, I want to move to the method of formalized reasoning. So in the mid of 20s, when people started to adopt the earlier concepts of mathematicians such as Gauss, linear regression itself, they start to think, what will happen if we would embed the human knowledge inside the rule-based frameworks? And thanks to that, they believed, and as the result, they achieved transparable, explainable, and clear systems that could guide and navigate the researchers, the practitioners, all the scientific technological foundation to the clean path of decision. Why it matters? Because it gives ourselves, and for the, let's call it AI, the explainability. We could understand how the decision is made. But next, we progress in the middle of the 90s, where we understood that the system which is made strictly on rules and follows only the only path that we created for them is not adaptable. It's hard to scale it. It's hard to share it. So if we create it for the healthcare, which was the first one was myosin, designed to classify the bacteria types, you could already feel that if you make the decision tree specified for one bacteria, for a couple of bacteria, you could not scale it across the whole world, since the bacteria types evolve, etc., etc., etc. As the result, our good old-fashioned AI obtained a shift, in this case, the paradigm shift. We switched from explicitly defined rules to data-driven models. In this case, it's the connectionist models. So the neural networks, thanks to the previous generations of experiments, thanks to McCulloch-Pitts, who developed the neuron, thanks to Rosenblatt, who connected it all in the perceptron, thanks to Rumelhart, who created a backpropagation algorithm. So thanks to all the previous generations of research, we achieved, only in the 90s for sure, but we achieved the model who could learn, adapt, and train based on data. So we had, but what was the biggest problem with those, if you could remember it, which we addressed as the result, but still, everyone called it bad because of it. Any idea? Overfitting? Not really. You call it black? Yes, exactly. The neural networks introduced the black box challenge because we could not trace why this decision was made. We see the weights, we see the connections, we see the model itself, so we know how big it is, how hard it is to train, but we do not know what exactly made the model to give that decision. Additionally, it enhanced the areas of the computer vision, so the CNNs, the NLP with the RNN, at the same time with the backpropagation LSTM, etc., etc. So it started a lot of momentum in the AI world. But once again, since the crowd or the audience of the AI, the world was not ready, we we encountered another AI winter, the second one in this case, when the one reviewer made a review on the global how AI looks like, presented it, and immediately the world stops to develop AI. So it's like a bit unfair from this side, but nevertheless, I would like to see his face now when he would see our progress nowadays. Next one, since we arrive and progress further, we see that the world is changing, the models itself are changing. So as soon as the attention is all you need appeared in our minds, in our society, it switched from the directly neural networks as we see now, from a little bit different structure, but still not for this. But this gives us the new possibility to combine advancement of neural networks with their adaptability, scalability, and data-driven approach with the reasoning, traceability, decision paths of the previous generation, which was symbolic AI. As the result, we achieve the hybrid model, which is nowadays called neurosymbolic AI, which gives us a path and the adaptability to any problem. And I would like to mention that it's very important in the domains where the decision and how we make that decision is very important as the decision itself. So this could be the medical term, the finance and law, since if we give the sentence for the prisoner, we need to be sure why we get that sentence. Not only that he's guilty. Yeah, that's fine, but why? And as the result, this blend of two technologies, one with the previous one, so basically two previous ones, we achieve the better and more generalized version, except, no, not except, instead of using them separately. Yeah. And I know that this happened very short, but this is the conclusion from my side. And I would like to mention that this journey from the ancient visions and symbolic representations of the data, of the models, of the vision of the past, through reasoning, through rules, through models, through networks, through all the past generations, past approaches, past history, and we arrive today in the world of the agents, which once again we have agents, but we combine them in graphs. So we use the same approaches that we used 50 years ago. But this is our like a one big quest, how we could go further, how we will advance further, how we will innovate further if all the ideas that we have are not new under the sun. If we just rethink what exists, what we will rethink next and how we will rethink that. So this was my main seed to plant inside your minds that innovation is not something that is very new to us. It's just old good things with a new case. And with that, I want to empower you and say to you, to everyone who is here, step boldly into the future, empowered by history, with the previous progress, with the previous lessons, and drive and think of the AI as the innovation with a new package. So that's it from my side.